Today we are going to discuss about what type of questions are being asked in the competitive examination. So let us start with conic section. Here in conic section, the most basic points is eccentricity, that is SP by PM. As it is the focus, and P it is a point on that graph, and PM it is the perpendicular distance from P to M, P to the directrix. This PM it is the perpendicular distance. So the ratio E is equal to SP by PM, which is eccentricity, and the questions are asked on this very formula. So directrix, because it is a straight line, so here comes the equation of a straight line, and next is the focus, it is a point, P it is also a point, so here comes our distance formula. So on this basis, SP is equal to, for say parabola, for in case of parabola your eccentricity is 1, so SP is equal to PM, and from here the data will be given to you and you have to find the equation of the parabola. Similarly, for ellipse, your eccentricity is less than 1, and here again the SP, distance SP and PM, that is the perpendicular distance from the directrix, and you know that the in straight line the distance formula from any point P x1 y1 to a straight line ax plus by plus c is equal to 0 is d is equal to modulus ax1 plus by1 plus c divided by root over a square plus b square. So here you see different types of formulas are used, and such type of questions are being asked. And in hyperbola, your eccentricity is greater than 1, and for circle, your eccentricity is 0. Now, next, the important point where the questions can be asked, we that is S and S dash. We know that in case of ellipse, and this is for especially for ellipse and hyperbola, we know that the S and S dash, the ellipse has two focus, and let P be a point on the ellipse. So here the sum, that is PS plus PS dash, is equal to 2A. That is PS plus PS dash is equal to 2A, and this is a constant. And this is 2A for when your focus is in x-axis. In case of y-axis, if the focus is in y-axis, then SP plus S dash P, SP, because ellipse has two focus, one is S and another is S dash, and P is a point on the ellipse. So SP plus S dash P, in case when the focus is on the x-axis, it is 2A, SP plus S dash P is equal to 2A, and this is constant. And when the focus is along the y-axis, then your SP plus S dash P is equal to 2B. Here it is plus, but in case of hyperbola, it is minus. That is modulus of SP minus modulus of S dash P is equal to 2A in case of transverse axis, and modulus of SP minus S dash P is equal to 2B in case of conjugate axis, and this remains constant. So these are the basic points which you must remember, and the questions are likely to be asked in this theory. So now let us come to say matrix. In case of matrix, no doubt there may be questions to solve any matrix. There may be to find out inverse. But to find out inverse, it is a lengthy process because you have to find that is adjoint of A by modulus A. So here, the problem here is that to find out the adjoint of A, first of all, we have to find out the cofactor and then we have to transpose. When you transpose the cofactor, we get the adjoint of A by modulus A, that is determinant A. So it is a lengthy process, and in the competitive examinations, such a type of questions, it is rare being asked. But using properties, it can ask questions using properties. So the important properties which you must remember, that if A and B are symmetric matrix, then your AB can never be a symmetric matrix, and A minus B will be your skew symmetric matrix, and AB plus BA, it will be symmetric matrix, and AB minus BA, it will be skew symmetric matrix. Again, I am repeating it. That is, if A and B are symmetric matrix, then A into B, A dot B, it is not a symmetric matrix. A minus B is a skew symmetric matrix, and AB plus BA is a symmetric matrix, and AB minus BA is a skew symmetric matrix. This you must remember. Now, next is that A into adjoint of A is equal to adjoint of A into A is equal to modulus of A into identity matrix. This is an important property, and another important property is that your modulus of adjoint of A is equal to modulus A to the power n minus 1, where n is the order of the matrix. This is an important property which is usually asked. And next important properties like adjoint of AB inverse, the whole inverse is equal to adjoint of B inverse into adjoint of A inverse. Similarly, your AB inverse is equal to B inverse dot A inverse. And the most important property is that if A square is equal to A or A cube is equal to A, then A is an identity matrix. So the possibility is that questions in competitive examinations using these properties, the questions may be asked. So you must remember all these things. And the last important property, that is matrix, is that if determinant of A is 0, then it is a singular matrix, and if determinant of A is not equal to 0, then it's a non-singular matrix, and if determinant of A is 0, then it is inconsistent, and if determinant of A is not equal to 0, then it is consistent. That means you are going to get the value of A inverse, and therefore you are going to get the value of x, y, and z. Now, these are all about your matrix. Now, here you must also remember that sum of n natural numbers, that is 1 plus 2 plus 3 plus dot dot plus n, is equal to n into n plus 1 by 2. Sum of squares of natural numbers, that is 1 square plus 2 square plus 3 square up to n square, its formula is n plus 1, 2n plus 1 by 6, and sum of cube formula, that is 1 cube plus 2 cube plus 3 cube up to n cube, it is n plus 1 by 2 the whole square. Apart from this, you must also know the expansion of e to the power of x, that is 1 plus x plus x square by 2 factorial plus x cube by 3 factorial, and it goes to infinity. 1 plus, again I am telling you, the expansion of e to the power of x is 1 plus x square by 2 factorial plus x cube by 3 factorial, plus it will go to infinity. Similarly, you must also know that log 1 expansion of log 1 plus x, it is x minus x square by 2 plus x cube by 3 minus x cube by 5 4. So expansion of log 1 plus x is x log 1 plus x. The 1 plus x is included into log, so this will be equal to x minus x square by 2 plus x cube by 3 minus x cube x4 by 4, that is x minus x square by 2 plus x cube by 3 minus x square x4 by 4, and it goes to infinity. Similarly, you must also learn this log 1 minus x. These logs are Neperian log because its base is e and its expansion is minus x square by 2 minus x cube by 3 minus x square by 4, and it goes to infinity. And expansion of sine x, that is x minus x cube by 3 factorial plus x5 by 5 factorial, and it goes to infinity. And expansion of cos x, that is 1 minus x square by 2 factorial plus x4 by 4 factorial, and it goes to infinity. So this expansion and the sum of n terms, square, sum of square, sum of cube, this all you must remember. And at the same time, the sum of if it is in AP, the sum formula is n by 2 bracket 2a plus n minus 1 into d, and if it is in GP, then a bracket 1 minus r to the power of n by 1 minus r if r is less than 1, and a into bracket r to the power of n minus 1 bracket close by r minus 1 if r is greater than 1. So why I have told you to remember all this expansion? Why? These are practically used. These are practically used to solve limits, thus to solve the questions of limits. So how this expansion and how this L hospital rule helps you to solve these questions. Now, here I am going to show you the application of L hospital rule, a question where it is suitable to apply L hospital. Your question is limit x tends to a, then bracket a plus 2x to the whole power 1 by 3 minus 3x to the whole power 1 by 3, the whole divided by 3a plus x to the power of 1 by 3 minus 4x to the whole power 1 by 3. I am going to repeat the question again. Limit x tends to a. In the numerator, it is bracket a plus 3x to the whole power 1 by 3, and then minus your limit x tends to a. In the numerator, it is a plus 2x. Remember the question, a in the numerator, it is a plus 2x to the whole power 1 by 3 minus 3x to the whole power 1 by 3 divided by 3a plus x to the whole power 1 by 3 minus 4x to the whole power 1 by 3. If you put the value of a, we are going to get it 0 by 0. Here, if you apply L hospital rule, if you apply L hospital rule, so in the numerator it is a plus 2x to the whole power 1 by 3. Its derivative will be your 1 by 3 a plus 2x to the whole power minus 2 by 3 into 2. So your answer comes 2 by 3 divided by a plus 2x to the whole power 2 by 3. And similarly, if you differentiate 3x to the power 1 by 3, it will come out to be 1 by 3 1 by 3 into 3x to the power of minus 2 by 3 into 3. So here it comes out to be 3 by 3 by 3 by 3 means your 3x comes to the denominator, that is to the whole power 2 by 3. And similarly is the case with the denominator. Here you see here you can easily place the value of a and you will get the answer. So again I am repeating the same question, that is your question is that limit x tends to a, in the numerator it is a plus 2x to the whole power 1 by 3 minus 3x to the whole power 1 by 3. This is in the numerator, and in the denominator it is 3a plus x to the whole power 1 by 3 minus 4x to the power of whole power 1 by 3. Here if you place the value of a, you are going to get 0 by 0. But if you apply the L'Hospital rule, what happens? The If you're going to apply the L'Hospital rule, the constant in the numerator and the constant in the denominator are different, as a result of which you are not going to get 0 by 0, and you can easily place the value of a and you will get the answer. Now I am going to show you a question where the expansion of 10x is required, where the expansion of 10x is required. The question is limit x tends to a 10x by x to the whole power 1 by x square. Your question is your question is x, limit x tends to infinity and x tends to a, and 10x by x to the whole power 1 by x square. uh, in the question there was a slight defect, that is I told you limit x tends to a. It is not x tends to a. It is limit x tends to 0. Now bracket 10x by x to the whole power 1 by x square. So here you see that limit x tends to 0, 10x by x, its value is 1. And 1 by, if you 10x by x, its value, limit x, its value is 1. And 1 by x square, its value is infinity. So the question is 1 to the power of infinity. To solve such questions, what we do, we use that e to the power of, remember, e to the power of limit x tends to 0 fx minus 1 in the bracket into gx. Remember this. That is, this is an important formula. Here the question, again I am repeating it, that is limit x tends to 0, 10x by x, it is inside the bracket, to the whole power 1 by x square. So here limit x tends to 0, 10x by x, it is 1, and 1 by x square is 1 by 0, that is infinity, 1 to the power of infinity. Now to solve such questions, what we do is that e to the power limit x tends to 0 bracket fx minus 1 into gx. So it becomes e to the power of limit x tends to 0, 10x by x minus 1, because fx minus 1, 10x by x minus 1 into gx, that is 1 by x square. So your, it becomes what? e to the power of limit x tends to 0, e to the power limit x tends to 0, 10x minus x by x into 1 by x. So it is 10x minus x by x cube. So your now it becomes like this: e to the power of limit x, e to the power of limit x tends to 0, 10x minus x by x cube. Now here to solve this we require the expansion of 10x. To solve it we require the expansion of 10x, and the expansion of 10x is x plus x cube by 3 plus x 5 by 5 up to infinity. So, and because e to the power, remember again, e to the power limit x tends to 0, 10x in the bracket, 10x minus x by x cube. So expansion of 10x is e to the expansion of 10 is x plus x cube by 3 plus x5 by 5 dot 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 minus x. So x cancel out divided by x cube, and if you take x cube common, so your answer will come out to be e to the power of 1 by 3. So so you see here that the expansion of 10x is required to solve this limit problem. In limit, some of the important formula you must remember, that is limit x tends to 0 log 1 plus x by x is equal to 1. Again, limit x tends to 0 a to the power of x minus 1 by x, it is also 1. And limit x tends to 0, 1 minus cos x by x is equal to 0, and limit x tends to 0, 10x by x is equal to 1. These formulas you must remember. Now let us move to trigonometry, where inverse trigonometry, there are some special cases which you must remember while solving the problem. The question here is tan inverse, and all these things are in the bracket. In the numerator, it is root over 1 plus cos x plus root over 1 minus cos x. This is in the numerator, divided by, in the denominator, it is 1 plus root over 1 plus cos x minus root over 1 minus cos x is equal to pi by 4 minus x by 2, and your x condition is given, it is greater than pi by 2 and less than 3 pi by 2. Again, I am repeating this question in inverse. This is an important question. Such type of questions are asked, and while solving, what is the point you have to remember to solve it? The question I'm going to repeat to you, that is tan inverse x. This whole thing is in bracket root over 1 plus cos x. This minus root plus root over 1 plus cos x plus root over 1 minus cos x. It is in the numerator, divided by, in the denominator, it is root over 1 plus cos x minus root over 1 minus cos x. So in the numerator it is plus, but in the denominator it is minus. This is equal to pi by 4 minus x by 2, and the condition given for x is x greater than pi and less than 3 pi by 2. So x greater than pi and less than 3 by pi by 2 means 180 to 270. X is in third quadrant. So while solving such questions, the second step, it is easy. That is tan inverse. Everything will be in the bracket in the numerator. 1 plus cos x, you all know that it is 2 cos square x by 2, root over 2 cos square x by 2, and plus root over 2 sine square x by 2. This is in the numerator, and in the denominator it is root over 2 cos square x by 2 plus minus root over 2 sine x by 2 sine square x by 2. So when you solve this root over 2 cos square x by 2, it will be modulus cos x by 2 uh, root 2, that means root 2 it will cancel out, the remaining thing will be, that is mod tan inverse. In the numerator it will be modulus cos x by 2 minus modulus sin x by 2. This is in the sorry, plus. In the numerator it is plus, and in the denominator it will be root over cos x by 2 minus sin x by 2. This modulus cos x by 2 minus modulus sin x by 2. So what is the result which comes out? That is tan inverse the whole bracket. In the numerator it will be modulus cos x by 2 minus modulus sin x by not minus, plus, and in the denominator it will be modulus cos x by 2 minus modulus sin x by 2. You write this modulus. Why modulus? Because we know that modulus it has, according to modulus function, the x it is either plus x or it is minus x. Plus x for x greater than equal to 0, minus x for x less than 0. We know about it. Now here comes our the condition, x greater than pi and less than 3 pi by 2. So since here your angle is x by 2, you divide it both sides by 2, you get x greater than pi by 2 and less than 3 pi by 4. So it comes in second quadrant. So here the x value comes in second quadrant. So here you are going to take this modulus cos x. Here you are going to take the value as minus cos x. And in second quadrant sign is positive, so it is plus sin x. And then the numerator similarly it will be minus cos x and minus sin x. So if you take minus common, it cancels out, and then only you will get that tan inverse 10 pi by 4 minus x by 2. If you do not do in such a way, the answer will come out wrong. So this is very important that you have to see the condition given to you, and if it is root, then you take as modulus, modulus cos x, modulus sin x, and as per the your condition given to you, then you can define in which quadrant it is, and as per the quadrant what will be the sign of the trigonometric ratio, you have to place that sign. So while solving trigonometric questions, this is very important. Similarly, there is another question, tan inverse root over a plus x divided by a minus x. That is a plus x and a minus x is inside your inside the root, and the condition given to it you is uh, that is x greater than minus a less than a. So here you are going to take that x is equal to a cos theta. So I am going to again repeat the question, that is the question is tan inverse root over 1, so not 1, a minus x divided by a plus x, root over, this is in the numerator it is a minus x and in the denominator it is a plus x, tan inverse. So this is the question, and the condition given to you is that x greater than minus a and less than a, and here you have to take x is equal to a cos theta, and now uh, again your result will be in modulus, and in modulus one thing is important in modulus. What is important in modulus is that uh, uh, inside the modulus, your um, mm, uh, uh, that is, uh, let me do the question again. Let me, I'm going to do this question verbally again. The question given to you, what is the question given to you is tan inverse. root over a minus x divided by a plus x. This a minus x divided by a plus x, it is inside the root. And you have, and the condition given to it, x greater than minus a less than a. Now you take x is equal to a cos theta. If you take a cos theta, a will be common 1 minus cos theta, and in the denominator it will be 1 plus 1 plus cos theta. So here comes out here this in the numerator it will be a cancels out, and then in the numerator it will be 2 sine square theta by 2, and in denominator it will be uh, cos square theta by 2. So inside the root it must be positive. So see, inside the root it must be positive. Inside the root. So your angle must be in first quadrant. Your angle must be in first quadrant. So modulus sin x must be positive, and your modulus cos x must be positive. So inside the root it must be positive. So negative root does not exist. So it will come out to be tan theta, and at last it will be equal to theta, and theta will be equal to sine inverse x pi. You have to take modulus x, and you must, no doubt, you must, while solving this, must come into your brain, that is you must think that it is theta by 2 and theta by 2, and both must be positive. Only then the root will exist, so it will be in the first quadrant. So in this way, the theta must be in the first quadrant, and then only you are going to get a tan theta, and so tan inverse tan theta will be equal to theta, and theta will be equal to sine inverse x by a. Now my next question is in increasing and decreasing function. This is an interesting question as well as it is an important question. See, fx, it is given to you sin x plus 3x minus 2 by pi bracket x square plus x bracket close, where x belongs to close interval 0 to pi by 2. See, again I am telling you the question. Fx is equal to sin x plus 3x. Fx is equal to sin x plus 3x minus 2 by pi, again bracket start, x square plus x, and again bracket close. Your means x square plus x is inside the bracket, and it is multiplied by 2 by pi. And so I will show you this, how it is increasing in the interval 0 to pi by 2. So here you see that at first, in 0 to pi by 4, in the interval 0 to pi by 4, fx, first of all, we will find out f dash x, and is f dash x, it comes out to be cos x plus 3 minus 2 by pi bracket 2x plus 1. This will be your differentiation. And in the interval 0 to pi by 4, it is increasing. F dash x is greater than 0. You can place the value and you can see that it is greater than 0. But in the interval 0 pi by 4 to pi by 2, because the interval given to you is close interval 0 to pi by 2. So now in the interval close interval pi by 4 to open interval pi by 2. I have taken on to open interval pi by 2 because you can take close interval also, because cos pi by 2 is 0, no doubt. In no doubt cos pi by 2, you can take close interval from pi by 2 to the close pi by 4. In the first case, from 0 to pi by 4, close interval 0 to pi by 4, your f dash x is greater than 0. It is increasing, but for the rest part is from pi by 4 to pi by 2. Here you see that the main factor is 2 by pi 2x plus 1. This is the main factor. So here your x is greater than pi by 4 and less than pi by 2, like greater than equal to pi by 4 and less than equal to pi by 2. Here the interval is x. Now you multiply it both side by 2 and then you add 1 to the both sides. You are going to get that is 2 by pi 2x plus 1 is less than 3. So since this value is less than 3, so automatically f dash x is greater than 0. So it is increasing. So this is how the question is solved. The interesting point here is that you have to show increasing in the interval 0 to pi by 2 close interval. Now, in the interval 0 to pi by 4, close interval 0 to pi by 4, it is f dash x is greater than 0. But in the interval pi by 4 to pi by 2, here you see that x close interval, you can take close interval because cos pi by 2 is 0, no doubt, but there is plus 3. So here x greater than equal to pi by 4 less than equal to pi by 2, multiply both side by 2 and then add 1 both sides. So here the result will come out to be 2 by pi 2x plus 1 is less than 3. So since it is less than 3, so 3 minus 2 pi 2 pi bracket 2x plus 1, this will be greater than 0. So it is increasing in the interval 0 to pi by 2, close interval 0 to pi by 2. Next, the question here is, this is also a case of an increasing and decreasing function. The question here is, for what value of a, for what value of a is fx, your function it is given to you minus x cube plus 4ax square plus 2x minus 5 is decreasing for all real values of x. So here the question is, again I am repeating you, for what value of a the function is minus x cube plus 4ax square minus plus 2x minus 5 minus 4ax square the question is fx. Again I am repeating the question, for what value of a the function fx that is equal to minus x cube plus 4ax square plus 2x minus 5 is decreasing for for every value of x belongs to real number. So first of all, we are going to do first derivative, and your first derivative comes out to be minus 3x square plus 8ax and plus 2. The first derivative, it comes out to be minus 3x square plus 8ax plus 2. Here the interesting point is that to show decreasing, there must be two conditions. This is very important. To show decreasing this quadratic equation, first, the coefficient of x square a must be negative, and second, your b square minus 4ac must be less than 0. Here, your b square minus 4ac is 4a the whole square minus 4 into minus 4 into minus 3 into 2. So here 64a square plus 24. Now a square, this can never be equal to 0. So there is for no value of a for which it is decreasing. The most important point here is that you must remember that if a quadratic equation, if your ax square plus bx plus c equal to 0, if your a is negative and the second condition is b square minus 4ac is less than 0, then your function is decreasing. So this is an important question. Now next, let us see about a function to find the domain and range. This is also an important question, that is fx is equal to log bracket 2x minus 3 divided by 5 plus 4x bracket close plus sine inverse 4x plus 3x by 2 minus x, 4x plus 3x by 2 minus x. Now For sine inverse x, we know that it is in the range from sine minus 1 greater than equal to minus 1 and less than equal to 1. So here your 4 plus 3x by 2 minus x is greater than equal to minus 1 and less than equal to 1. From here, you get the value x greater than equal to minus 3 and x less than minus 1 by 4. So, minus 1 by 2. So, from here, you get the result x greater than equal to minus 3 and x less than equal to minus 1 by 2. So, here your x belongs to the closed interval minus 3 comma minus 1 by 2. This is the case for sine inverse x. Now we go for log. For log, we know that log x, the value of x must be positive. So 2x minus 3 by 5 plus 4x, it must be greater than 0. That means there are two cases, either the both numerator and denominator must be greater than 0 or both the numerator and denominator must be less than 0. So 2x minus 3 must be greater than 0 and 5 plus 4x must be greater than 0. From here, we get x greater than 3 by 2 and x greater than minus 3 by 4. From these two, the intersection point will be the result. So your x belongs to your open interval 3 by 2 and infinity. This is your common section. This is the intersection point. And similarly, for less than 0, you are going to get x less than 3 by 2 and x less than minus 5 by 4. So here your common point, that is intersection point, is x belongs to open interval minus infinity to minus pi by 4. So the union of these two, that is minus infinity to minus 5 by 4 open interval, union 3 by 2 and infinity open interval. This is the first case. And in the sine inverse x, we got a closed interval, that is minus 3 and minus 1 by 2. From these two results, that is these two results means x belongs to open interval minus infinity to minus pi by 4 open interval, union open interval to 3 to infinity, both are open interval. And next is x close interval minus 3 and minus 1 by 2 close interval. From here we get the result, that is the your domain will be x belongs to the common area, that will be close interval minus 3 to open interval minus 5 by 4. So this is how domain is calculated. So this is also important questions which such type of questions are usually asked in your competitive examinations. And now, in case of binomial theorem, you must know the formula, that is 1 plus x to the power of n, that is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube plus it will carry on. Similarly, 1 minus x to the power of n, that is equal to 1 minus nx plus n into n minus 1 by 2 factorial into x square. Again, then it is minus n into n minus 1 n minus 2 by 3 factorial into x cube. So here in log 1 minus x, it is alternative plus minus, and in 1 plus x to the power of n, it is all are positive. So these are the things which you must remember. And next, the important thing which you must remember, that in straight lines, in the equations of the in the equation of straight line, usually questions are asked, that is what will be the coordinate of your image, what will be the coordinate of the foot of the perpendicular. So here, if p is a point, that is coordinate is x1 and y1, and the straight line is ax plus by plus c is equal to 0, and its image point is q, which is x2 y2. So by the help of this formula, that is x2 minus x1 by a equal to y2 minus y1 by b equal to minus 2 bracket ax1 plus by1 plus c divided by a square plus b square, by the help of which you can find the coordinate of your image of the point P. And if you have to find the coordinates of the foot of the perpendicular, then your formula will be x2 minus x1 by a equal to y2 minus y1 by b is equal to minus bracket ax1 plus by1 plus c bracket close divided by a square plus b square. So such type of short forms and such type of formulas you must remember, which will help you in find out the coordinates of your image of the point P, as well as to find out the foot of the perpendicular. Next, an important formula is in trigonometry, that is cos A into cos 2A into cos 2 square A into cos 2 to the power of 3A into dot dot dot. It will be go carry on to cos 2 to the power of n minus 1 a. Your result is sine 2 to the power of n into a divided by 2 to the power of n into sine a. So this is also an important result in the trigonometry which you must remember. So questions based on this formula are also asked in the competitive examinations. And in case of your vector, that is three-dimensional vector, in case of three-dimensional vectors, the questions are generally asked the shortest distance between two straight lines. In case of vectors, three-dimensional vectors, questions are generally asked the shortest distance between two vectors. And sometimes the questions may be also asked, that is your mm, the equation, that is the question like this question: let the length of the lattice rectum of an ellipse x square by a square plus y square by b square equal to 1 be 10. Its eccentricity is minimum, is the minimum value of the function ft is equal to t square plus t plus 11 by 12, where t belongs to r, then a square plus b square is equal to. So here you see there are two set. One is the set of the equation of the ellipse, where the equation of the ellipse, and in the another state it is a function, it is given to you, and you have to that is a b10, and the eccentricity, that means your it is let the length of a lattice rectum of an ellipse x square by a square plus y square equal to 1 be 10. Its eccentricity is the minimum value of the function. That means it is, see how the question is related. Here the question, first part of the question is your ellipse, and in the second part it has the eccentricity. It has told you that eccentricity is the minimum value of the function t square plus t plus 11 by 2 12. So this is how the questions are related, and then you have to find that this a square plus b square. So you all know that first of all, function it is given to you, and by the help of second derivative test, or by the help of you can second derivative test, you will find out the minimum value of e, and from that, when you get the value of e, and you know the length of the lattice rectum. So by the help of lattice rectum and E, you can find out the value of A and B. The most here, I remember this is an important question for you. That is the lattice rectum in the case of parabola, it gives the aperture. Lattice rectum, it gives the aperture. So if there is a question whether this parabola is inside this parabola, then you will compare it by the help of lattice rectum. Remember that the lattice rectum, it gives the aperture. The greater the aperture, that means your lattice rectum will be greater. So by the, if a question is asked whether a parabola lies inside another parabola, then you can find it, you can analyze it by the help of the lattice rectum. So These are the important points which I have told you. And next, suppose a reason is given to you. That is, it has been defined the relation that is xy such that x less than equal to y less than equal to 9 minus 11 by 3 into x square and x greater than equal to 0. Here the relations such as are xy, where x is less than equal to y and less than equal to 9 minus 11 by 3 x square and x greater than equal to 0. So here there are two type of equation. One is x is equal to y and another is y equal to 9 minus 11 by 3 x square. The here you know that any quadratic equation it is a parabola. So y is equal to 9 minus 11 by 3 x square. Here your when x is equal to 0, your vertex will be at 9 and the aperture will come downward, and y is equal to x, that is the graph here you get, and the intersection point will be somewhat like your x-axis. The parabola and the straight line will be somewhat like x-axis. You have to take x-axis. So now here the length of the rectangle is your y is equal to 9 minus 11 x square minus x, that will be the length. 9 minus 11 by 3, 9 minus 11 by 3 into x square minus x, that will be your length and your breadth will be x. So area is x into 9 minus 11 by 3 x square minus x, and you have to find the largest rectangle. So by the help of your second derivative test, you can find out the value of x, and from that x you can find the maximum area of the rectangle. So such type of questions are the probable questions which are asked in usually asked in any competitive examination, either it is NDA or JE means or say CEE or say CUT. Such type of questions are asked, and in case of complex number, it is a simple. You must not be afraid of it, because the only main property it is the which is generally utilized is z into z bar is equal to modulus z square, and that is modulus z square. It is also is equal to modulus z square by we say z square modulus z the whole square is equal to z square modulus. So both are the same. So here you need not have to be afraid of it. For complex number or for log, you need not be afraid of it, because the such no tough questions are asked in this. Log, it is generally in most of the cases log are related to find the domain, and in most cases it is used to find the limit. So log is generally used in to find the domain, or say to find the uh, limit. This is all about your problems which are generally asked in competitive examinations. So I think so. In a short time, I have been able to uh, make you the whole syllabus of the and the type of questions which are probably asked in the competitive examination. Similarly, in some cases, that is tan inverse x plus tan inverse y, the conditions, that is tan inverse x plus y by 1 minus xy, this condition is satisfied if x into y is less than 1. And next is pi plus tan inverse x plus y by 1 minus xy. This condition is satisfied if x is greater than 0 and y is greater than 0 and xy is greater than 1, and minus pi plus tan inverse x plus y by 1 minus xy if x is less than 0, y is less than 0 and xy is greater than 1. So such conditions must be fulfilled. If such condition is fulfilled, then only you can use the formula.